GRIP has 3 aircraft: the Global Hawk, which is an unmanned aerial vehicle. We have the DC-8, which is a large airliner that will contain quite a few instruments, and that will fly at the height of normal of airliners, 30, 40,000 feet. The Global Hawk, the UAV I mentioned, will fly at an area of around 60,000 feet. And then the third aircraft is called the WB-57, and it also is a very high altitude aircraft. It will fly around 60,000 feet, and it will carry the instrument HIRAD, on which I'm the PI, or principal investigator, and it will also carry another instrument, AMPER, the Advanced Microwave Precipitation Radiometer. And my job as platform scientist is to represent both of those instruments and to represent the WB-57 from a platform perspective in the discussions of where we're going to send these various aircraft, at what times, what kind of flight patterns, and so forth. HIRAD, or the Hurricane Imaging Radiometer, is a new instrument that extends technology that's currently used by NOAA and by the Air Force to fly on airplanes, fly through the storm or over the storm, and measure the intensity of the winds at the ocean surface. The instrument that they currently use can measure the winds directly below the aircraft. So basically it has an antenna that just points straight down and gets a measurement straight under the aircraft. HIRAD is a new development that will enable us to see not only directly under the aircraft, but also 60 degrees to the side of each side of that directly nadir view, so that as we fly through or over a hurricane with HIRAD, we'll be able to map out a full two-dimensional view of the wind field. The way HIRAD works is that it senses the microwave radiation coming from the ocean surface at specific frequencies. And we know that these frequencies are determined, the intensity of the radiation at these frequencies is determined by the wind speed, among other things. The wind speed determines the frequency, the intensity of these frequencies through stirring up waves which generate foam, and it's the presence of sea foam that causes the intensity of the radiation to increase as a function of the frequency. By measuring several frequencies, we can get information about the wind speed as well as the rain rate. The microwave radiation that HIRAD senses is emitted from the ocean surface. It's very similar to the microwave radiation that's used in a microwave oven that cooks our food. It's just at a slightly different frequency, and of course it's very, very much lower intensity. So the ocean surface gives off these this microwave radiation. Basically, of course, everything that's not at absolute zero gives off radiation in an entire spectrum, and the physics of these things are very complicated. But we know empirically from a lot of experience through the past 30 years that that measuring the microwave intensity in these frequencies from the ocean surface can give us a very good measurement of the wind speed across that ocean surface.